All right, so welcome to this stream. So today I'm gonna try to implement the AI for the Sudoku game that we worked on the last time. So let's just get started. And here I'm gonna share the screen like that. Okay, so basically, if we run the program, what we did last time is we built a single player Sudoku game where you set it up yourself and then you could kind of solve it. You could do the scribbles to mark out potential numbers. And then in this way, you could basically play yourself. So what we need to do is to implement an AI that tries to solve the rest of a Sudoku. And to do that, there are a number of different algorithms you can use. So I would say that one category is like human inspired algorithm. That's, like humans do it. So we have some different heuristics that are used when you try to solve Sudokus. It could be like, if I do like this, here we can easily see that okay, there's a problem in this one. Let's change this. So here that this one is going to be a 2. That's how humans do it. uh, um, Other patterns are if you have kind of like pairs where you can say that they're mutually exclusive. There are things called X-wings and all these kind of patterns that we humans recognize and use to solve a Sudoku. And then there's another family, which is basically computer-like. And I'm going to go for that one. And it's basically brute force, where you try all combinations and see what works and what doesn't work. That's easier to implement on a computer and will work just fine. So basically, the way I think about it is that what we do is that we just, we have these scribbles that mark what the numbers are possible in each cell. And what I want to do is that I want to maintain that set of what's legal in each cell, and then basically enumerate them and try them depth first, and see if we can solve it like that. So it's gonna, so in case there is a solution, it should find it. The problem with this algorithm is that it's slow. In the worst case, because there can be a lot of search going on. But I'm not going to be too worried about this in this particular stream. So to do that, the first thing I'm going to do is that I'm just going to implement a function that will calculate what are the possible values in each cell, right? Because that's going to be the starting point. So I'll just try to do that. So I guess we can add a button. So here, text button, we can call it help. Why not? And what this one is going to do is basically we have this, if we remember here, the data structure, we have the scribbles, which are the pencil marks for each cell, where we have a set of what numbers are possible inside that. Okay. So what I'm going to do is I'm just going to say, we're going to put in the full set of values in each cell. And then we're going to basically just update all of the what's called scribbles, yeah, like this with that set. So now they are fully filled out, and then we're just going to update the correctness of the board, because we have a function that will reduce that set to what's possible. So let's see if this works. So we'll just put in some numbers here and there, and let's see if I click help. If it does, now you can see it does. It seems it does the right thing. So now we have this set of possible values. Okay, so in principle, what I want to do is that start with some cell like this one, and then try to put a 2 in here. Okay, then it will update all the possible things. And then if there's no error, we'll just continue to the next cell and say, okay, let's try 4 here and see if there is any errors. No errors. Let's try 3 here, and then 1 here, and then 5. And in this way, keep going. And we have the property that as long as there are numbers available in the set, we can always put it in, because this set is updated. So we'll just pick the first one in each of them. And if we keep going like this, but now we have a problem. These 3 guys are empty. And that means there is a conflict. We can't solve this Sudoku. So and what I need to do is basically undo the 3 here. I don't have an undo, so maybe that's a good idea to implement undo. So let's try to do that. So undo is basically recovering the state from the previous step, right? So we have the state of the Sudoku up here. So what we're going to do is that we're just going to say, take a snapshot of that state, and then we can recover it. So let's just say we have a Sudoku snapshot, and that's going to be a board of its. We don't need them to be behaviors. We can just keep them as they are, and then we need this the scribbles. Those are the 2 things that are interesting for this particular purpose, right? Those are the ones we want to be able to undo. Okay.
Maybe deltas will be more economical in sense of memory consuming.
Sure, but you know, as I often say, I think correctness is more important than optimizations first. So I like when you're doing something complicated, a general principle to me is that make it work first, and then you can optimize later.
That makes sense. Thank you.
Get snapshot. So we have this where we take a state, and then we extract a snapshot. So this one is pretty simple. So let's implement this one. We do a map of the, let's find that. It's called board and scribbles. Okay. Board and scribbles. So this is a row, map the row, and we get a cell, and it's like get value of the cell, right? Okay, so we can just say get value like this. All right, that's this one. And then scribbles, I guess it's pretty much the same thing. Row, map, row, get value. Okay, let's see if this compiles. It does indeed. So what we'll do is that we'll add an undo stack up here. Undo stack, so it's a list of snapshots. And we have to make sure it's initialized here. And it has to be a ref or behavior. I guess we can do a behavior. That's what we do other places. So behavior is fine. Okay. And then what we need to do is that whenever we do a change, we have to record the snapshot before we do the change. Okay. So if I remember correctly, we have a function called update cell or something like that. Yeah. Change the cell to this number, this particular one. So the first thing we do is that we get a snapshot and update that and push that to the list. Snapshot gets snapshot from the S, and then we're gonna say next S undo stack cons, whoops, cons of snapshot comma get value is snapshot. Okay, like this, I believe. Get snapshot expects 1 argument. Maybe it's I called get Sudoku snapshot. Yeah, there's another get snapshot. That's not the one. Like this. Okay, and then we want to have an undo button. So let's do that. M text button undo. It's basically undo stack. So we have the undo stack. And if there is an element on it, we'll undo it. If not, there is nothing to undo. So if this is the empty list, there's nothing to do. But if it is a cons, then we have a state and the tail, so to say, the rest. So we need to say set Sudoku snapshot. Set Sudoku from snapshot, maybe. That's what we want to call it. So we have a snapshot and we want to nudge like this. We want to put that in there, and then we want to update the undo stack to be the rest of the stack, right? So we need to implement this one, which is the reverse of this one, so to say. We have a Sudoku, and then we have a snapshot. And we're gonna say iterate, I guess that's the one. Whoops. Snapshot dot board. We're gonna get the y coordinate and we're gonna get the row, and we're gonna iterate over the x coordinates and this row x cell. And then we're gonna say next distinct is board y dot x comma cell, like that. I guess we could also do the scribbles at the same time. So snapshot scribbles y x, like that. Okay, and after that we gotta update the correctness, I guess. Or is that required? Let's think about it, because if we did, there wouldn't be any errors. Highlighting doesn't really matter. I don't think we have to update anything. This should be sufficient, right? For at least for our purposes for doing the algorithm. Let's just try it out. So I'm going to put 2 there, undo it, and click undo it. I can't undo again. That works. I'm going to put in some numbers like this. Undo. Oh my, oh my. Okay. So these are some nice building blocks. Of course, if I wanted the undo to be nice in the UI, I would have to do the update highlighting and all of that, because yeah, it's like this, right? So if I undo now, it's still red, but it's not a problem. So I could consider to just do that afterwards, undo when you call it manually. So I'm going to move this to be an undo function, and then you can call that undo Sudoku. And in this way, we can have the best of both worlds. When we're doing the algorithm, we don't have to do exhaustive calculations, but when we're doing the UI thing, we can do it. So where was the function? Up here. So we'll just say like this, and then we'll update the correctness afterwards. Okay, so let's just check if that helps with that particular bug. 2, undo, now indeed it works. Great. All right, so basically the algorithm is going to be that we have some state on the board, and we're going to basically click help, so to say. We're going to do this one, and then just pick a cell and try 1 here and 4, and in this way proceed like before. But if we reach an empty cell, we undo the previous cell and pick the next number. So that's going to be the algorithm. So basically there are 2 loops inside each other. One loop is over each cell, and the other is what are the options inside each cell. So that's going to be what we're going to try to do. So I guess we'll just do a button called solve, which is going to solve it. So the first thing we'll need to do when we solve it is to calculate this help thing. So we'll just make a function out of this. So update possible scribbles. Let's call it like that. That should work. Okay, so that's the first thing we do in here. And then we have to have some state. So we're going to say do solve Sudoku. So we have this guy going on, and then we need to have the cell, the next cell, and then the option in this cell. All right, and then we're going to keep going. And maybe we need to return whether we are successful or not. Maybe. All right, let's just try, see if we can get this to work. So we start in cell. Let's just make the numbers, the top numbers, the top cell 0, and then enumerate them in reading order. That's a way to do it. Okay, so no, in fact, maybe we should do it like this instead. We're going to go for this cell first. We're going to solve this cell. And if the cell is bigger or equal to 9 times 9, then we're done. Right? Let's do it like this. Otherwise, we're gonna say what are the options in this cell, and it's gonna be we're gonna convert the cell number into coordinates like this. Scribbles. So now we get the set of possible numbers in here. Okay. So if is empty set, if it's an empty set, then something went wrong. We can't handle this cell, and we have return false. Let's do it like that. Otherwise, we're gonna try them one by one. We're gonna say try Sudoku options. Let's call it like that, just to give it some name. And here are the options, remaining options that we're gonna try. Maybe we should do the check inside this function. Okay, let's see. Anyways, Sudoku and the cell and the options we have for this cell are here. I think this check should be in here, now that I think about it. So let's do it like this instead. Okay, so if it's the empty cell, otherwise we're going to pick up the first one. So we have a set, and we want to pick out the first element of a set. There's a pop set. Yeah. So these guys, they can pop an element from a set. Okay, and that will in fact return if the set is empty, we're gonna get none. So we can do it like this instead. So we're just gonna pop the set, and if we have a value, then it's like the value is mrest.value, and the rest is mrest.rest. Okay, and then in this case, that's where we didn't the set is empty. Okay, so now we're going to try to place this value in that cell. So we'll repeat, we could maybe say X and Y here instead, so we don't have to redo that calculation. Why not? So here what we want to do is we want to update the cell to that value. So where is that? We have the update cell function here. Update cell, selected cells to that number. Okay, and we don't want to do the, so it's only part of this we want to do. It's only, in fact, this thing, and then update correctness. Okay, so we'll just do that manually. So here, and this is the value. Okay, and then update correctness, update correctness. So, so in fact, it's only this errors part we need. No, we do want to update the other possible values after each step. So I guess that's going to be okay. And we want to, well, so it's not going to be completely efficient to just call this one, but I think that's going to be okay. We'll just do that for now. So we set this up, and then we're going to update the correctness, and then we're going to say if there's an error. What was the errors? Oh, we don't have just a summary if there is an error or not. I guess the error will be in this cell, won't it? If there is an error, it's probably going to be in this cell. Am I correct? Yes, it can't be in other cells. So it should be okay to just check this guy. If this cell has an error, then we know there is an error. Like this, if there is an error, it didn't work out, and we have to try another value. So what we're going to do is that we're just going to call this guy with the rest. Okay. Otherwise, we're good to go, and we just say true. Okay. So this one will try to find a value that works in this cell. Up here, if this works, we're good to go to the next one. So we'll just say cell +1, Otherwise, we have to backtrack, which is false, right? Are we backtracking correctly now? I guess we are. But maybe this is not the right thing to do here. We have to call the same cell again. Let me think about this. I think this is not correct. I don't think this can backtrack. So we have some more work to do. What is it talking about here? Okay, this one returns. All right, so let's just do a test. So maybe what we should do is, instead of doing the full board at first, we'll just try to solve a small part of it. Just one grid at the top 3 by 3. That's going to be simpler to test that. I don't think this is going to work, but let's see what happens. So I'm going to put in some numbers here and then see if we can solve it. But it didn't. So what happened? I guess we should have some printing. So let's say, oh, we forgot to undo. We have to undo the Sudoku in case there was a problem. Okay. And I guess we have to store it. We do have to store the undo before we try it out. Should we do that here? Yeah, it should be correct to do it here. No, it's not sufficient. We have to do it here. So we have to record the undo thing in, where was that in the update? Oh, the update cell does it. It already does. So that's fine. All right, so let's add some print so we can see what's going on. So here we just say, okay, trying to solve cell. Maybe we should print the possible options. Options. Okay, we can just say toString. That's gonna be fine, like that. Okay, and then we are saying using trying okay, and then we're gonna say failed succeeded. Okay, let's try this, and maybe that gives us a few insights. So we don't have the backtracking capability, I'm quite sure, but I hope that this at least will trying to solve cells 0.0. Okay, we have an off by 1, I guess. No, that's correct. It's just that it's not 0.0 is this one. Okay, so if there is an entry in the cell already, we don't have to solve it. It's already solved. So that's what we have to do here. So if get value is board y.x is different from 0, we're good to go. We just continue with the rest, right? Like that. Like that. That should make a difference. So let's try that now and see if that makes a difference. Solve. It said already trying cell with options, trying 1, failed 1 in 1.2, which is strange. Why are the options these? So something's wrong with the options. Didn't we calculate update possible scribbles up. So here, and when we, so that's surprising, isn't it? It shouldn't have all of those. And it did something strange here. So clearly something's wrong. 1, 2, 3, 4, 5, 6, 7, 8. Let's try it just like this, solve, and then it becomes 5. So something's up. Oh, I'm still 3 divided by 3. Yeah, this is correct, isn't it? If I want to go to 9, let's just see if we visit all cells.
You have 81 cell, so you should divide by 9.
Yeah, but I want to do a subset of it. I just want to solve this first one, so it's a little bit easier to work with. My intent is only to work on this one particular box. And so let's try to print the value we find in here. It's basically this one. So now it should print 1, 2, 3, 4, 5, 6, 7, 8, 9 if I put them in here. Just check if it does that. Solve 1, 2, 3, 4, 5. That's correct. So it does look at the right cells. But for some reason, when I the scribbles are gone, right? So something's wrong. The scribbles are not correct. So update possible scribbles. Oh, it doesn't do the update. Okay, that's correct. So something's wrong here. It has to do the update correctness as well. That's the bug. Like this. Okay, let's try that again. So now, okay, now we don't want the true anymore. Okay, so that worked. And if I undo, let's try to solve this. 8 and 9, that worked. Let's try to solve this. 7, 8, 9, that worked. Okay, and let's try to put a 8 here, forcing the 8 to go here. That probably won't work. No, it won't work because it's not able to backtrack at this point because the error happens later. So let's try to figure out how to solve that. So the problem is that if we try to solve a cell, we have to backtrack here. If this didn't work, we have to go back and try another one, right? A previous one. Is that how we want to do it? No, we don't want to do it like that. What we want to do here is that if we have some options here, let's think about it. So let's say we're trying the first cell, and we had 2 options in there. And then the next cell, we had 2 options, and then it turns out none of them worked when we tried number 1. That means the second cell has to go back. So I'm wondering if I should have one loop only. If this is wrong, then I have another function here for this guy. But if this fails, we know it's not possible to put one in here. So if this one fails here, maybe it is correct just to go back. If the cell is bigger than 0, we'll just go back. No, because we have to not try the same one again. So whatever we tried in this cell, okay, I think the thing is that this call should be happening in here. So basically, this function should call this one up here and make sure that the rest of it works here. So here, this one should go and complete the entire Sudoku, right? If it can do it. Otherwise, it's not a success. I think that's the way to think about it. So let's add the cell here as well. Try Sudoku options here. And then we're just done here. This one doesn't recurse. Okay, I think that should be correct. So let's try that. So what did I do wrong? This guy needs the cell as well. Yeah. Okay. So let's try the same thing. 4, 5, and then we're going to put an 8 here and forcing this one to become 8. Solve. It becomes 6. So it didn't work. So let's see what was wrong. We tried.
Empty options.
Yeah, that's it. It can't solve it. So it's like here, it's in this cell. It has to come back and try this one again when it didn't work out. Okay, so this one can return.
Next value should be tried.
Next value should be tried. Yes, I agree. It has to backtrack. So basically, we need to have a stack of all possible options in each cell. So I'm wondering if so let's say that we have an empty set here. This guy has to backtrack. So it has to try. So when there is no options in here, the error happened earlier. Okay, so whenever we have a false here, it has to undo and go back and try a previous cell again. So it shouldn't, for each cell, before we move on.
Exclude from options and try again, maybe.
Okay, that's possible. So just restart from the start. Of course, that would work, but maybe that's too much, but fair enough. You're right, that would work. So if we have a failure here, then we try the rest of them. That's fine. That's where we're trying inside the cell. But if it worked here, it's in here. So this we have no choice but to backtrack, right? So what we could do, I guess, maybe we should have a different data structure instead of just so is it here, and then we go down like this. Let's just say we have these options, we have these options, and we have these options. So we're trying this one first. That's happening here in this call. And if that works, we check if everything else works as well. If it doesn't, then we have to backtrack on this cell. So what's wrong? So it doesn't go back and backtrack here. So it's kind of like too late when we find out there's an empty cell. So we put in the 1 for some reason, and then we find out it doesn't work later down. Then we are still in the call stack of cell 1 here, trying the different options, aren't we? So why isn't that correct? So I guess here, this case is something, we have to do something else here. No, it just bubbles up. Is it this one? No, it's not. That's fine, I believe. So for some reason, we don't backtrack when Okay, so let's see if we don't succeed here, we should try the other options. I think that's it, right? This is it. So if this works, we're fine. Otherwise, we have to try the next option here. Failed later in, and then we undo and try the rest. I think that's it. So what did I, okay, these guys are wrong. Okay, so let's try that again. 1, 2, 3, 4, 5, and then we put an 8 here, and then we try to solve. Then it says 9. Okay, so something happened. We completely failed. So let's see what the trace is. Trying to solve. Should we clear the undo stack here? Could it be that we have something on the undo stack we don't need? I guess we may have to pop that. Anyways, we should probably add a print for the when we undo and when we push. So trying means we push, failed means we pop. I think we have to pop here, right? Otherwise the undo stack just grows. So I think we have to undo this one without undoing it. So it's like pop, undo. I'm not sure that's the mistake, but that seems logical that we wouldn't want to just increase the size of the undo stack like that. That should do it. So whenever we push something on the undo stack, we have to pop it. So this one pushes something, so all branches have to pop something. And I think that has to be this one. All right. And in that case, we're good to go. Okay, let's try that. See if it makes a difference. Nope, that didn't make a difference. So let's see if we can see. Now we're trying 6. We're trying the next row with 7. We're trying the next row with 8, and then it's empty. Failed later, and then it's going to go back and try 9 in this one. That's correct. And then it tries the next one, and that trying 7 in which one? In 2.1. That's the top one. So it's trying 7, and that worked. And that trying 8 and 9 worked. And then it failed later. Why? Maybe I should fix the numbering because it's a little bit confusing that the coordinates are off. It's going to be easier if they're more human to read this. Maybe I should just give the cell numbers because we're putting 1, 2, 3, 4, 5 in there. That's even easier to debug, right? Like that. Okay, let's try to print it again, see if we can trace what's going on. I guess we should have a print here. Oh, is there a sequencing problem? I don't know. Anyways, let's put this in here so we can just see what's going on.
You now have a mix of human readable and non-human readable numbers coordinates.
Thank you. You're right. You're right. Thank you. It's probably a function I should have used for this, but anyways, that's okay. We can also change this one and just say plus cell like that. Now it should be consistent. No, not here. We even have this one. Okay. And I have a bunch of them running. Let's just close them all. Okie Okay, so let's try again and see if we can figure out what's going on. We put an 8 here, forcing an 8 up here. And then it says 9 for some reason. Trying to solve cell 5 with options this, that's correct. Trying to solve cell red, and it failed in 6. So now it's trying 9 in 6, succeeded. So that's fine. So, and then it's trying to solve the rest. They should fail. Now it's going back to trying to solve failed 5. So trying 8 in 5, that's correct. That should succeed, and trying. So why doesn't that succeed later? So for some reason, it doesn't have any options after backtracking to 8 here in cell 6. So when we try 8, when we backtrack, it doesn't have the correct state, I guess. So the undo part is wrong. I guess maybe what we should do, instead of having the undo stack, we should just record the state here and remember it. So instead of, we'll not call undo, we'll just say, what is the previous state? Existing state. We'll just say get Sudoku snapshot. So it's on the stack and we don't have to rely on.
Maybe you shouldn't remember current available scribbles, but calculate on each step. Don't to be afraid they are becoming invalid at some step.
Sure, but I think it's correct to remember those scribbles. It has to be correct. So I think we'll just change it to be explicit like this, existing state, or like this. That should be correct. This one doesn't need anything then. And here we'll just undo like this. Okay, so in fact we don't want to push stuff on the undo stack here, so maybe we should update. Oh, but we didn't. Oh, that's the problem. We didn't use the update function call, right? Okay, so that explains it. We never pushed anything on the undo stack. Okay, so let's try this now. I think this is correct. Put 8 here and then solve. Oh my God, it worked. All right, so I think that's it. If we just generalize to the entire thing, to do all cells, it should work. It's probably going to run really slow. So, but let's try it out and just put some numbers here and there and see if it can solve it. I bet if I run it now, it's just going to say solve, it's going to print forever, but it did. Oh my God, it worked. It found a solution. There you go. So I guess that's it. We'll just get rid of the prints and then we're good. We have the solver, a Sudoku solver. All right. So any questions or comments? Maybe there is something in the chat. Let me see if I can find the chat.
Probably no questions and no comments.
I guess everything is just very clear, right? So to summarize, basically, depth first, search over all possible options, and maintaining that updated set all the time. And we already had that code. Yeah, so I guess I guess that's it. I think the next time what we could do is that we could use this function to generate Sudokus, right? So it's like to generate a Sudoku, you want to fill in some numbers until there's only one unique solution. Okay. So and a good Sudoku only has one solution. This one has many solutions, and the solver will just find the first one. But we could use the solver to check if a given state has more than one solution. It's basically just backtracking. If this one returns true, then just remove one of the options in the first cell and see Well, we probably have to change a little bit to do that, but that would be a nice way to generate a unique Sudoku. So we'll just put random numbers in cells, check that it can be solved, and there's only one solution. And once there's no more than that, we would have generated the Sudoku with a unique solution. But I think that's something for the next time. So with that, I'm just going to say thank you very much and see you next time.
Thank you. Bye.
Oh, there is something in the chat. Yeah, yes, exactly. So, okay. Bye-bye.